So before we start the actual webinar, and while we're giving another minute for other people to join, I'm gonna try to answer some questions that came up. One that I saw was about a gallery view. If Grist would get a gallery view. Currently, there is a card view, but it doesn't quite work for a gallery view. I'll say that at this time we don't have a plan to add a gallery view, but a custom widget can be used for this purpose. And I think I've seen some similar ones in the community. So that's should be possible basically to build one for your current needs using custom widgets. But for a built-in feature, it's not on a roadmap at this time. Another question was really more about like a particular formula that really needs ordered lookups. So rather than answering that, I'll do the actual webinar, and that will, I think, essentially answer that question for a good way to do that sort of thing. And let's see how many people we have. So, and I guess I'm about ready to start. So welcome, everyone. The last webinar, which was year in review for 2025, is recorded, and the recording is online. So you can find the recording on our website if you missed it. For this webinar, the topic is, we named it Advanced Formulas with Ordered Lookups, which is kind of a crazy topic. So I'm kind of excited by how many people are here because it sounds advanced and it is kind of an advanced feature. We weren't sure how to explain what it's about. So this title is the best so we could come up with. If you're completely new to Grist, this webinar kind of will start you off at the deep end, but fear not, it will still be useful. If you're a regular and you were hoping to see Natalie, who normally does our webinars, she's on a parental leave. So that's a very good and positive reason for her to miss a couple of webinars. Okay, so as you probably all know, Grist has powerful formulas with Python support and support for many Excel functions. I see some other questions in the chat, but I'll get to them at the end of the webinar. So where was I? Grist has powerful formulas, Python support, Excel functions, and that makes it easy to do calculations within a row. So actually, I'm going to show a few right now. So for example, in this payroll example, which is a template I'll use for things later on. But here's an example formula that just shows a typical Grist formula. And maybe I can zoom in a little so you can see better. You can refer to another field from the same records using dollar notation, so $hours, dollar per hour, current rate. You can multiply them. You can apply functions like round to a nearest cent. And it works very nicely and simply. Grist also has reference columns, and that allows tying records to other records, which is what makes data relational. And that's why people talk about relational databases. So references are very convenient in Grist formulas, make it easy to do calculations with relational data. And we can try an example in this same template. For example, let's say that here in this list of payroll, I have a reference to a person, and I want to see the person's name maybe formatted in a different way. I can add a column, and I can add a formula where I take the person's, let's say, person's full name. Actually, let's take person's first name, and I can add a space, and I can add the person's last name. And if I want, I can put uppercase the whole thing. And it just works as you expect. But unlike an Excel formula or something here, this is looking up a value from another table from the people table because person is reference to the people table, and references allow me to access that record in this very kind of convenient notation without, it tells me exactly what I'm accessing and how, which field and so on. Compared to Excel, this is much more readable and clear. Also, in case you are new to Grist, I'm here editing a formula in a cell, but actually in Grist, a formula applies to the whole column. So I could click on any cell to edit a formula there. So this was just an example. I'm going to delete this. But what I was trying to do is illustrate how formulas can refer to other records. But what if your calculation needs to include data that's not in the same record and it's not available via reference? One kind of situation is summary tables, like if you want totals or subtotals, reports. Often when you make charts, you want to group and summarize data. And summary tables are a special feature of Grist for this purpose. And essentially, we have an example here, I think, as well. Like this is a summary table. This list icon shows it's a summary table. Essentially, it gives you a reference list called $group, which refers to all the records that are being summarized. And you can use a similar notation to look up values from particular fields and do calculations on them. And another situation is lookups. You might not have already reference, like reference value, but you may have the same, for example, email address in two different tables. Maybe these tables came from different sources, and you can use a lookup to find another record and return a reference. We have an article on lookups that I will paste into chat, and I will collect all the links later into a recording. But this is our article on lookups. And I'll show an example of what a lookup formula looks like. That will be useful for later. Here's an example from like event management template, where here we have a table of registrations with an email address, and elsewhere we have a table of sponsors with also an email address called contact email. And if we want to find a sponsor, if this person is also a sponsor, we can use a lookup formula which looks like this. We say sponsors, that's the name of the table you're looking up in, dot lookup one, that you're looking up a single record, whose contact email field is equal to this $registration email, which is the registration email field from this current record. And here you can see, like in this table, two of the emails are found in that other table. So that's lookup one. In practice, it's using a single lookup like this, lookup one, is actually quite rare, since it usually makes more sense to organize your data with references. So it's more common to look up all related records together, and for that there is a function called LookupRecords, plural, and it returns multiple records. And actually, we'll see plenty of it today. So lookups work well when you know exactly which value you're looking up. But what if you don't? For example, so this is where ordered lookups come in. For example, what if you're trying to find the previous record to the current record, previous by date or by timestamp? For example, we have a ledger or a list of orders or a history of incidents and so on. What if you want to find the first or last record of a group, like the first event of the month or the last communication for a particular customer? What if you find the largest order for a customer, sorting by amount or something? What if you want to find the most recent tax rate that's in effect for the current record, before it came into effect before a certain date, for example? What if you want to find the applicable discount here? So this is all examples of situations where ordered lookups come in, and that's what we will be talking about today. I'll also say that whenever you need to do cumulative calculations, or like running totals, running balances, that you also need this kind of cross-record lookup, where you don't know exactly which value to look up in the record, and you need this kind of ordered lookup for it. Ordered lookups is not a great name necessarily, but you'll see why I call it that in a minute. I'll also want to mention that this kind of functionality is considered advanced. You don't need it always, but it does come up fairly regularly, and serious data products have to support it. So it is possible in databases using SQL. It is possible in Excel, but it's never simple to do. And I'm glad to say that it's actually relatively simple in Grist. So I think Grist offers a very nice mechanism for ordered lookups. And another point I want to make is that for those who are happy to use Python and formulas, it is possible to do any of these things by writing enough Python code, because you can look up many records, kind of, and scan through them and find what you need. But it's very hard, even if you're good at Python, it's very hard to make that efficient when you have a lot of data. And the problem that these methods solve, and with using some special mechanics in the data engine of Grist, besides convenience, is also efficiency. They work much faster, and replicating that on their own is difficult. So when these methods that we'll talk about, when they fit your problem, you should use them. So let's start with cumulative calculations, like running totals, because they're more common and simpler to use. The example we'll look at first is this credit card activity, which comes straight from a template we have by the same name in the template gallery. But here I will be adding a running balance. So let me give you a little bit of an overview of what's here. Basically, we just have some transactions. Each transaction has a date, description, amount, card member, because maybe it's an organization and different members have cards. And it has a bunch of other stuff that's not important here. What's important for us here is, given this amount, I wanted to write this to calculate a running balance. These transactions are sorted by date. In fact, that sort is specified right here, that it's sorted by date. And I want each of the following transactions to update the previous running balance with the current amount to get the new running balance. Now, if you were doing it in Excel, that's just the previous row. But what if you sort in a different way? In Excel, that would just break your calculations. In Grist, you can actually have different views of the same data. So for example, like here, I'm looking at things sorted in this way. I could have a different page. In fact, I do have other pages where I have the same data that's shown per card member, or that can be ordered in a different way or filtered in a certain way. So it's we can't just rely on what you see. We have to say in the formula what we mean by the previous row. And you do that using the previous function. So I guess I'll just, I already wrote this formula, so I'll just open it to show it because it's faster. But the important thing here is this function. The function is called previous. It is spelled in uppercase, previous, kind of by analogy with all the Excel-like functions that Grist supports. Because the formulas are actually Python, which is case sensitive, it does matter whether you spell things lowercase or uppercase, and all the kind of Excel-like Grist functions that Grist provides are spelled uppercase. Previous is not, there is no analogous Excel function, but we spell it uppercase just because that's how other ones are spelled. So uppercase previous, the first argument is the special variable rec, which represents the current record. And the other argument is order underscore by, all lowercase, equals, and then the name of the column that we want to sort by. So this is what tells us that we want the previous record by date rather than the previous record by something else. When you use this function, it essentially looks at the current table, sorts it by date, finds where this current record falls in it and looks and returns the previous record. Once you have that previous record, you can use the dot notation that we use for references. In fact, that record is a reference. And using the dot notation, you can take dot running balance, which is the previous balance. And then that's the previous balance. And then you add the current amount, and then you get the new balance. And that's how it works out. In fact, I'm a bit curious to just type it out again in the new column. So this might be a copy of the running balance. And I'll take it step by step, so it's a little bit easier to see what's happening as we do it. So first, I'm writing previous, the current record, and I want to tell it what to sort by, and that's the order by field. And they say which fields to order by. This field is called date, so I'm typing in date. This is just the name of the field, so I don't use a $sign here. If I stop here, what I get is an actual reference, a reference to this previous record. If I want to do a running balance, then I need the running balance from the previous record. And this column is called running balance 2, because I already have 2 columns named that. So use running balance 2. And that returns me the running balance from the previous record. But for now, everything is blank. Well, let's put it in a variable. I'll call it previous. Previous balance, let's say. And what I want to return is previous balance plus amount. And a common thing you'll see when you do this is this error. And why do we see an error, and what does it mean? This says unsupported operand types for plus. We're adding 2 things, and one of them is none, and one of them is float. Float is just a Python name for numeric, but none means that one of the amounts is blank. And the amount that's blank is for the very first record, which does not have a previous. So the previous running balance is none. There are 2 ways to solve it. One way is you say up here, if you don't have a value, you use 0. And that solves it and gives you numbers. The other way to solve it is if you turn this column into a numeric column, you go to greater panel, column, select column type to be numeric. That changes kind of the layout, makes it look better. You can make it look like, with $signs, you can change set currency and so on. But one thing it does is now, even if you didn't have the 0, now that it's numeric, it knows that for a missing records before the first one, that default value for running balance will be numeric. It'll be numeric 0 value. So we wouldn't have that error even without the or 0. But that is a subtlety that you will run into if you're doing numerical calculations using previous, so wanted to point it out. Okay, now this is a running total across the whole list of transactions. But what if we wanted a running total for a particular account or particular card member, or by category? One thing that we always advise in Grist is if you have data of the same shape, like if you have transactions for different accounts, but the transactions are the same kind of record, then they belong in the same table. There are various reasons why that's an advantage, and that's all part of the dry principle. Don't repeat yourself. And in Grist, it's convenient, even if you then want to see data separately. If you want like one page for this account, one page for that account, you just create different views on the same data that's filtered in different ways. Or you can have a linked view where you have a card to member in this example here, and you can select the card member and see the activity just for that card member. So, but in this case, how would you get a running balance just for the card member rather than across the entire table of transactions. So let's take, so I already did this here. So this is a balance per card member, and it's a formula that's a little bit different from the one we looked at before. So let me open it and let's take a look. Once again, we use the previous function. This previous function now has one extra field. We're saying previous relative to the current record, and we want to group by card member. So this is similar to order by, but we are saying group underscore by, all lowercase, equals card member. And then we still want to order by date. And from this previous record we are finding for this card member, we will look at the previous balance. If it doesn't exist, which it won't for the first records, then we'll use 0. And we save it in a variable. And as before, we add the current amount to this variable to get the running balance for this current record. So that's an example of previous using both order by and group by. And one thing I wanted to mention is that formula values, they never depend on the view, because the same data could be viewed in different ways by different people. The formula just has a single value. It doesn't depend on the view. It doesn't depend who is looking at it. They only depend on the data and the actual code in the formula. So this column will have a running total by card member, no matter where we look at it. If here in the activity, for example, I say show this hidden column balance, it was visible in the other screen, but it's not visible in this screen. If I show it, it's showing the same values for the same people. Actually, let me move it where I can see it more easily. All right, so here for this card member, Dudley, there was an amount of 40, the running balance 40, the balance for Dudley is 40. When there is another 40, it's 80. And the next person is not the same with Clara Dudley, it's a different person. So the running balance across everything adds this amount to the running total. But this balance, which is per card member, this number doesn't look right because it's not, because this is the running balance just for Vera and not for Claire. If I were to sort it, on the other hand, and just show Claire, then for Claire, this running balance would be correct for Claire, and this running balance would look off because it's including a bunch of records that we are not seeing in this view. So this is important to realize. Basically, if you want different calculations grouped in different ways, or using different ordering, you will have different formulas. And then decide which one is better to show in which view. Again, because formulas do not depend on the view. So let me do that. I wanted to look briefly at a more complicated example, which is a loan tracker example. I won't go too much into details because it's more involved. But here, basically, we have an example where we have like a loan. We have multiple loans in the same document. There is some loan amount, term, interest rate, calculate scheduled payment, and so on. And in each row of the payments, it needs to do a bunch of calculations to figure out from the previous record, what's the remaining principal, calculate the interest on that principal according to the loan terms, and then figure out how much of this payment goes to the principal, how much goes to the interest, and so on. One thing that's a little bit different here is we have a lot of these calculations will use data from the last row, and this last row is a reference column that is just this kind of previous formula that we were looking at. It's still the same formula previous. Now you're grouping by loan because I have different loans here. I only care about the previous record for the current loan. I'm ordering by date again. Ordering by date is very common. The column here is also called date. But I'm not doing anything else in this column. I'm just returning that value, that reference value, and my column type is in fact a reference to this same table. So this is a table called schedule, and this is a reference to the same table, but it's returning a different row from the same table. And then I have various formulas that use this column. For example, I have maybe quite a lot, but like the start principal for this row will be the last row's outstanding principal if the last row exists. And then if the last row doesn't exist because it's the first record, then I will use dollar loan initial amount, which is what the loan started out with. So you can basically use previous and more complicated ways. I also wanted to mention that you can group by multiple columns if you need to. You can order by multiple columns if you need to. For instance, if I wanted to, well, this formula, for example, does group by. If I wanted to group by card number and category, I would put card number and category in a list and called a Python tuple that's surrounded by parentheses. If I wanted to order by different things, I could order by date and then the date by amount. In a similar way, put in parentheses with commas between them. If I want to order by increasing versus decreasing, I would add a minus. This would order by date descending. This would order by date ascending and by amount ascending. And if I put a minus here, it would be by date ascending and by amount descending. So all of that is possible. And I should paste in and actually link to the documentation. But since I don't have it prepared, I'll also show you how to find that link on your own. So you go to support.getgrist.com. If you've seen this site before, it looks different now than it used to. Better. We've improved the look of this site. And here you can search for LookupRecords. There's different articles about it, but function reference is a useful one. And here's LookupRecords. And this goes into order by and how to use it. So let me paste this link into the chat for your reference. Okay, this is not the end. This was the previous function. The way this, sorry, two more functions that I want to mention. One is called next, all uppercase next. Just like previous, actually, previous is documented on the same page. Sorry, that's the link I should have been posting. I apologize. I was ahead of myself. LookupRecords is the next function I will describe. This is the previous function. Similarly, there is a next function. It's just like previous, except instead of looking backward in the list, it looks returns to the next record in the list. That's much less often used, and especially since in previous you can change the order with a minus sign. So it mainly exists for symmetry. And there is a function called rank, and rank returns the number of the records in a sorted list. Now, so basically the first record will return a rank of 1. The second would be a rank of 2. I haven't found rank useful very often, but one time it's useful is, for example, if you want to find, for example, the top n transactions, let's say top 10, then you could use a formula like this. Let me show that in this example with a credit card. Let's say you want to hide this column and this column, and instead I will say, I want, is it top 10? Top 10. And I can write a formula like this, where I want to rank the current records in a list ordered by amount descending. So the largest amount first. And if that rank is less than 10, that means it's in the top 10 transaction when ordered by descending amount. And for most records, it's false, and for some, it's true. And if we use this like filter, we will say that actually exactly 10 records match true, and those would be the largest 10 records. Maybe we can filter by that, actually. say these would be like my largest 10 transactions in this data set. So that's when rank might be useful. The way previous is implemented is actually using ordered lookups. So let me look at an example where we need an ordered lookup, but it's not previous. And a good example is in this payroll template. This is actually, we have a template that goes over this example. So I would like to paste that into chat as well, because you can then find it on your own later. But in this example, we have people, and for each person, we have a rate, an hourly rate that they get paid. And this, we keep track of the history of rates because the rate may change. Somebody might have a raise or be in a new role with a different rate. So we have a history of this. And whenever there's a payroll, we need to use the correct rate for this payroll. So this is where unordered lookups comes in. And the formula for that is here in this per hour table, I believe. So let's look at this carefully. We are trying, so this payroll has a particular date that we are running it on. That's the date of the payroll. And we want to find the last rate that applies to this date. So the first thing we do is we do lookup records. This is the same lookup records I mentioned earlier, but here we are looking up in the rates table all the records for this current person for the given role, right? Because they, this example, they work in a particular role, so we need the rate for that role. And the very important thing that makes it an ordered lookup is that there is an order by argument to this lookup function. And so that's the special argument that causes the resulting set of records that it finds to be sorted by rate start. And rate start is a field in this rates table. Just show you that that's where this field comes from. It's in that table that you're looking up, which field in that table to sort by. So that gives you a list of rates. And this is the second part of the magic. If you have a sorted list of rates, there is this method called set of methods under find, and this method is find LE. LE stands for less than or equal to. I'm finding the nearest record in this list that's less than or equal to the current date. This is the date in this table. So for example, if this is 2020 January, if it was this person that I'm looking at, Bertha. Let's see. So Bertha has two rates, and I'm looking for the nearest one to January 2020. Well, this rate starts later than January 2020. It's not less than or equal to. The only one that matches less than or equal to is this one from 2019. So that's the one I expect to see 110 here. And in fact, it is 110. So find less than or equal to returns the current rate. And then, again, as with any reference column, we use the dot notation to pick out the actual amount that's in the hourly rate column. This is spelled out with comments and in multiple lines to make it easier to read. You can write the same thing kind of in one line or without the comments to make it shorter. But all it does is we look up records, we say what to sort by, we use find less than or equal to the current date. There are other methods to find strictly less than or greater than or greater or equal to, and so on. So all of these methods are also documented in the function reference, and these are the find methods over here. So you can see that less than or equal is this method that I used here. Actually, I think that's the most common method that will come up. In all the examples, pretty much. By default, everything is ascending. If you wanted descending, you add a minus, and that worked for previous, and that works as well for lookups. So here in this payroll example, if I were to change this to minus rate start, then I would find the rate by descending, which is not what I would want for an example like this. Okay. The article I linked to also covers this. There was actually a similar example in the contractors, like for similar kind of rates for contractors that appeared in a recent webinar in how Grist uses Grist. If you're interested in that one, here's a link to that. But there was a similar example for looking up a relevant rate there. These kinds of needs can appear in very different cases. I prepared an example from, I believe, a spreadsheet makeover, which had a formula like this. This is kind of from before the ordered lookups. And this is a before and after example. So I'll just talk through quickly for the kind of thing you might see maybe even in your own documents. You've been using Grist for a while and haven't known about the ordered lookup formulas. So this is without the document. We'll just kind of imagine what the data looks like. But here we are looking up. So we have a column called order. The order has an event date. And then we look up some ingredients for a particular flavor. So I guess we have something that has an order and a flavor for some event. We need to find something for this particular flavor, and we need to find some entry that applies to the current date. And so the way you can do it in pure Python is you can use this kind of somewhat crazy expression that's called the Python list comprehension to say, for all the records returned from here, called cost, for all the costs, see which ones have an entry date that's before the current date, less than or equal to the current date, and then find the last of these dates. And then once you find this most recent date, you can look up records again. Actually, I think this should say lookup one. You're looking up like that one rate for this flavor, for this most recent date, get the cost from that, and multiply it by the number of whatever it is in this table. So this is complicated, and it's not efficient because every time it has to scan through all dates. With ordered lookups, it's kind of similar, but it basically saves a couple of steps and replaces them with one with more efficient steps, essentially, and simpler to express. So here again, we're looking up records for the flavor, but we can tell directly to the LookupRecords function that we want it sorted by entry date. And once we have the sorted list, we just use that same find less than or equal method to find the records in this list. Sorry, this is supposed to be called, I called it ins here before ingredients, just to keep it short. But in this list called ins, which is ingredients sorted by entry date, I'm finding the one where the nearest one or the last one that's less than or equal to this date. And what it's comparing is this entry date to this order date. And once I found one, most recent one, then I just take the cost times number, and this will be efficient. If you are into programming or algorithms or data structures, you'll be pleased to know, I guess, that this kind of lookup, it uses binary search. So that's a much faster way to find things in a sorted list, and it will be fast even if you are looking things up in a list of tens of thousands of records. Many of the above examples were with dates. That is a common use case. So I'll just want to show one more that's not about dates. Same idea, but not about dates. And first, I'll show it in Google Sheets to give you an idea of what kind of thing you might be converting from. So this is commission rate schedule for some sales. And the idea is if the salesperson meets certain sales target, then they get increasing commission rates based on certain tiers. And here have salespeople. Here's how much sales they made, and now you have to find the relevant commission rate based on this amount. And in Excel or in Google Sheets, you can do it using a VLOOKUP function or an XLOOKUP function, and it doesn't really tell you what it is, but you'll have to read documentation. And if you are, know it, then this value of true is what tells it that it wants an approximate matching. And what it means by approximate matching is that this table must be sorted, and it will find kind of the nearest thing that's less than or equal to. This is what it looks like in Grist. So I have the same table of sales targets. These are my commissions as percentages. These are my people and sales amounts. And to find the applicable rate, this is another good example for using the LookupRecords function. Make sure you can see the whole thing. In this case, I just put it all in one line. I could have used variables to make it multi-line and be a bit easier to read. But let's just try to read the way it says it here. I'm saying in the commission rates, which is this table, LookupRecords. I'm not saying to look up by customer, by count. So it's LookupRecords in this case returns all the records. All I want from it is for it to sort it for me, to order it by sales target. So it'll be records ordered by this. And remember, things never depend on the view of the data. If I were to come here and change this sort it downwards, for example, that does not change anything about my formulas. My formula says how I want it to be sorted. I want it to be sorted ascending by sales target because I don't have a minus here. And in this list, I want to find the item that's less than or equal to this current sales amount. So it finds the nearest item less than or equal to the sales amount, and from that item I get the commission rate, and this is my commission rates. So for example, if I change this 15 falls into, it's bigger than 10, so I get 10%. If I change it to like 10,000, it will still be 10%, but if I change it 9999, it's no longer greater than or equal to 10, so it will now find 7%. And once you have the rate, you can use a simple formula, multiply the rate by the sales amount, and you get the commission. So that's an amount that's not about dates. Anything that's based on tiers, shipping rates, volume discounts, tax brackets, all of those can use this approach. One last thing I'll mention, because I gave it as an example early on, and I haven't shown it yet. What if you simply want to find the first or last record in a group? For example, the last order for a customer. Here, I just put an example formula here in a slide. But for example, last order for a customer, you look at orders, you use lookup 1. Remember, everything else use LookupRecords. So what's different here? I'm looking up all the orders for where the customer field is ID. So all orders for this current customer. I am sorting them by date descending. So minus reverses the order. Instead of going in order, it goes in reverse order. So the last date is first. And the fact that it's lookup 1 rather than LookupRecords, it simply returns the first record it finds. And because I sorted it by date descending, this would be the last order for the customer. So that's all you need to do to find the last order for the customer. Lookup 1 and specify the correct order descending. If I change it ascending, it would be the first order for the customer. I do have an example that we can do quickly here just to illustrate how this works. And the example I put in here is in the payroll template. If you remember, we had potentially multiple rates for a person. If I want to find the current rate or the latest rate for a person, I can use a formula like this, where among all the rates, I look up 1, just return the first record for this given person. I will order by the start of rate. So I'm looking up in this table. I'm ordering by rate start descending. So again, the first one will be the largest rate start, so the latest date. And from that, I will take the hourly rate. So for example, here, if I add a new record, that's now it's the latest record. Now it's 0, it's returning 0. And if I change this record to something else, it's looking up this latest rate. But if I were adding it to a different year, let's say if it's not the latest rate, then the latest rate would be this record. And again, notice how it's finding the latest by date, not the latest by what I see on the screen. That doesn't depend on the view, depends on what's in my formula. My formula says ordered by rate start. So that covers everything I wanted to show. And I'm ready for questions. All right, if there were questions earlier on, you might need to repeat them. Okay, can you make reusable formulas that can be called in other tables? So in the ideal way to set things up in Grist is so that you basically have one table for everything that needs the same logic. And the formula will apply to every record in this table, like with the transactions or with payroll and so on. It applies to, a single formula applies to, every account, every category, every person. There are maybe, if you actually have different tables and you want to write the formula in one place, there may be very tricky ways to do it, but there's no good way. And it's not really recommended, it's rarely gonna work, because if your tables are actually separate tables, in all likelihood, there is something a little bit different about them, and then the formulas will have to be a little bit different. They'll have to name different columns, because formulas have named columns in them. Another question that Nick is posing from before, would using previous and doing a row by row be more effective than just simply doing it by dates? Yes, it would be more effective, more efficient. And here's the reason why. If you're doing this summation, I don't know if you can see in the chat, maybe I'll paste it somewhere where others can see. This is an example with a running balance, for example. So let me do this here and add a column. This is not quite the right fields because it's from a different example. I'm just showing you this formula so you can see what we're talking about. But you could, in principle, say, I just want to sum everything in all of my table for all the records less than or equal to the current date. And the reason this is much worse performance is that for every record, it has to scan the whole table, find the relevant records and add them up. So if you have 10 records, it's totally fine. But if you have 1,000 records and it's doing that scanning of 1,000 records for each of the 1,000 records, then that's 1,000,000 operations. And if you have 10,000 records, that's 100 million operations. So that's going to be several orders of magnitude slower than if you use ordered lookups. So I have a pretty clear answer to that question. So basically, if your document is slow, this is actually a kind of fairly common problem. Basically, if each of your formulas is doing a lot of work, and once you have a lot of data, your document gets slow. And then we have a formula timer that can help you detect which formulas are responsible for it. And if they're slow, then you can see maybe you can optimize it with ordered lookups. There is an interesting example here. I see conversion factors. We have a list of various conversions. Yeah. If you're trying to find kind of which unit is best used to describe something. Is it like a milliliter, a liter, for example, right? Then you might use another lookup here. For a table like this, which is, I think, generally going to be very small, it doesn't matter how you do it, because I think you'll be. I'm not sure exactly what you would do here, but definitely I can see that could be useful. So yeah, in Grist, I would make this into its own table and look up a suitable thing, but I'm not sure exactly what you're looking up here. Okay. Doing conversions and make. So if we are doing conversions, if you make it into a table, you can reference the table instead of rewriting it. I see. So I think is it the same person who asked about reusing formulas? Okay. Okay. So let's say that you often need to, like in many different tables, you have some kind of number, but it's with units. So here you have 8 ounces, and there you have 3 pounds, and you often need a formula where you need to convert it from one to another. Yeah, the formula itself will not be the same because your fields might be different, but it could be fairly simple in all cases, because if your conversions are in a separate table and you have from unit and to unit, then I think all you need to do is do a lookup 1 for a unit, because for any given I think you would do lookup 1 where you look the source unit and the destination unit, and presumably you just have like one row like that in the table, and then you would use the factor from that, and that's kind of just basically a single lookup 1 call, and then that conversion rate. So to make it into a Python function that is available to all documents, there isn't a way to make it available to all documents, because each document has its own kind of sandboxed environment. But within the document, it is technically possible to make a Python function available. You can actually write a formula that has a Python function inside of it, def, name of the function, and so on, and then return that name of the function. That's not like a typical thing to do, a normal thing to do, but it does work. And then you'll have to find that function using a lookup. If you have a table with a single record, basically, you can do a lookup with no arguments, lookup 1 with no arguments. It'll return a row from the table, and a value of a column could actually be a Python function. It's a little crazy, but I've seen it done. Tracking transactions. Each transaction will be logged into a specific column according to their original currency. Okay, so different currencies, different columns. And then I have one column that would show the equivalent value in dollars. Makes sense. Would need it to first search in which column the value was logged, and then a separate table for the exchange rates for that currency, but also exchange rate for the correct date. So that is exactly a perfect use case for ordered lookups, where you would do something like lookup records in the table of exchange rates, where you say currency equals the name of the currency that you figured out for the current record, order by date, and then you would use that .find.le for less than or equal, and put in the date of the conversion, so it can find the latest kind of exchange rate that applies to this conversion. So it's the same kind of thing that we had for payroll example. If you have multiple columns, figure out which one to use for currency. That would just be like a bit of custom logic. If this column is set, then this currency. If this column set, that currency. That could all be in one multi-line formula. Or maybe you have the original amount as a single column and a currency as a choice next to it, rather than putting things in different columns. That might simplify some logic. The any column is indeed kind of what you would need if you're returning things that are not real data. Like if you're returning a function, you could return such things in an any column. Okay. If somebody is asking for a link for example documentation, but returning a function. Oh, okay. I can look for it. I'm sure you could find it in our community forum because I think I've seen this before. All right. Thank you, everyone. I'll wrap up now. Have a great rest of your day.